And welcome back. Yes, now today we're going to be talking about sleep modes in ESP32 devices and specifically deep sleep mode. Yes, indeed, deep sleep, because if you're running off battery, that's probably the mode you want to be running your ESP32 in when you're not actively doing something. Now, you can, of course, turn off the Wi-Fi and Bluetooth separately to save a bit of power, but if you're doing that, you're still using power running the rest of the processor and the memory and all that. There may be a use case for that, but I would say that if you're going to power down the ESP32 to save battery power, then you probably want to shut down everything except the RTC, the real-time clock, because that's the thing that will wake up your device, either because a time has expired or because you've either pressed a button like this one on here, or like I'm doing in my smart workshop heater controller, the remote temperature sensor is also going to be detecting whether or not the power's on. So when the power comes back on, a pin goes high because the external power has come on, and the RTC says, whoa, power's come on, I'll wake up the device. And then my logic within the program has to say, why have I started? Why am I here? Have I started as a reboot completely, fresh out the factory almost, or was it a deep sleep restart? In which case the logic of your program could be subtly different. In some cases, quite a lot different. I want to do a big shout out for PCBWay, PCB Prototype, the easy way. Now, the first thing I want to bring your attention to is the SMT ordering lot, $30 for up to 20 pieces. So if you're a small business or want a sample run, this is ideal for you. Not only that, but they can do flexible PCBs, those bendy things you often find in cars and specialist machines. They will do those for you too. And if you're really at the high end of stuff, advanced PCBs, PCBWay have got it all covered. If you need it, they've got it. Finally, they can order custom parts. Now, this is a really exciting area that they're doing. You can have online CNCing, machine services, 3D printing, and sheet metal fabrication. Now, as you can see here, they do plastic moldings, aluminium, stainless steel, the lot. If you need some small prototype runs, this is obviously the place to come to. I previously mentioned the SMT assembly service that they offer. Let's have a closer look because hobbyists can make use of that as well. For just $30, you can get up to 20 pieces assembled, and they'll assist with getting your parts sourced and fitted. I mean, it sounds ideal for those small prototype runs. It's definitely worth checking out what PCBWay have got to offer. Find out today. Okay, so what this demo is doing is staying awake for 10 seconds and flashing that LED. And when the LED stops flashing, it means it's gone into deep sleep mode, like now. And the only thing that will wake it up is either the expiry of the real-time clock, which I've set for 10 seconds, or we can press that button like that, and it will wake up immediately. Now, let's have a think about deep sleep. If you've ever done it in Arduino mode, you can put the Arduino to deep sleep. And what's the maximum you can ever put the Arduino to sleep for? Hands up. Yeah, you at the back?
8 seconds.
Yeah, exactly. 8 seconds. Yeah, that's the maximum. After all, the Arduino is an 8-bit device, so it counts up the milliseconds in a little tiny variable, and after 8 seconds, it goes, that's it, time's up. That's the maximum. You can do it shorter, but 8 seconds is what you do. And then, in fact, that's exactly what I do for my storage bin lids out there. When they're raised up, they get switched on, and every 8 seconds, they go... Well, they've gone to sleep and they come out of sleep going, oh, the bin's still up. I'll send a warning and then go back to sleep again. And 8 seconds is all you've got. Okay. Now, if we fast forward to the ESP8266, the smaller brother of this one here, they can go to sleep for about, I think it's about 71 minutes, which is quite a bit more, but still not really what hobbyists want, is it? There's quite a few use cases out there where they want to go to sleep for an entire day and every 24 hours wake up. So what's the maximum amount of time then that you can go to sleep on an ESP32? And I'll give you a clue. All right, we're counting up microseconds in a 64-bit variable. So how long do you think that is? A week? A bit longer. Month? A year? No. You can actually sleep, if the thing doesn't crash on you, for 5 years. And really, 5 years. Well, that's if your battery lasts, of course. Yeah, you can put your ESP32 to sleep for 5 years if you really want. I don't suppose anybody's going to, but who knows. But it's nice to know that effectively the sleep time, deep sleep time on here is unlimited. It's great. I mean, you don't have to think about it. You go, yeah, go to sleep for 2 hours, go to sleep for 24 hours, 48 hours, whatever. Good stuff. Okay, so in order to get this little demo running then, I've wired up this LEDs that just flashes in the loop. That's all it's doing, waiting for the timer to expire until it goes, oh, there we are, look, it's gone to sleep now for 10 seconds. And after 10 seconds, the real-time clock says, right, your time's up, I'm waking you up. And once it's woken up, it then just goes around the loop again for another 10 seconds and then goes back to sleep. Okay, and as I say, the other way we can wake it up is by pressing the switch, which is also attached to the RTC. Yes, there we are. It's attached to the ESP32 as well, but also the RTC has access to that GPIO pin, and there are only a few available. Okay, let's have a look at the output log then, the serial monitor output, to see how this looks in real life. Right, here we have a blank cool term monitor. Now the thing's asleep at the moment, so when it wakes up, it's going to start putting stuff out into the serial monitor. There it goes. Now the thing that we need to look at is why are we awake? Yeah, the first thing it does is say, look, this is reboot number 135. Yeah, I know it's been running a while. And the wake up was caused by the real-time clock timer. So that means the 10 seconds or whatever I've put this to sleep for has said, right, time's up, go. Yeah. Now, obviously, it's gone back to sleep again. If I, oh no, it's awake again. Let me just press the button when the flashing has stopped, and we'll see the different message, not RTC timer. So if I press it now, there we are. Look, wake up caused by external signal using RTC/IO, which basically means one of the pins went either high or low, whatever you've specified, and yeah, you pushed it. Great. So those are the two that I'm using, because they're the two most likely. All the other stuff is available in the Espressif and or engineers webpage that I'm going to point you to, because it's good reading, and your particular project might need a certain tweak or whatever as to what kind of sleep mode you need. But just to reiterate on this one, everything on that ESP32 dies power off until the RTC wakes it up. Okay, that's the only thing that's running, but it will always go through the setup as though it were the first time. So your code has to say, why am I awake? Is it a reboot or is it something else? Was it pin A? Was it pin B? Was it the real-time clock timer that woke me up? And take the appropriate action within that. Now you're probably thinking, if everything's dead and then comes alive again, all my variables that I've set up are all dead as well. Absolutely, except there's a solution for that. You can put some of those variables into the real-time clocks SRAM. Okay, and I'll show you how to do that in the code walkthrough. You just say, put this variable in the real-time clock SRAM, please, not the ESP32's one. And that works very well, but there is an 8K limit. Okay, and remember that if you press reset or the power dies entirely, you've lost the lot. So you've got to take care of that. Maybe put them into little FS or SPIFs or something on the actual device, even an SD card if it's important. If you're logging, bees in the beehive or something, you don't want to put the count into the real-time clock SRAM and then have that die on you because all your information is lost. Okay, pretty simple. We'll do a walkthrough and I'll show you the code, and it really is simple. I urge you and recommend that you download the sample sketch that I've written, and most of which was taken from the Espressif documentation, I might add, and just play about with it and see how easy it is to put your device to sleep. However, do bear in mind this is very different from Arduino Deep Sleep. You put your Arduino into deep sleep, yeah, for a maximum of 8 seconds, but when the Arduino wakes up, it resumes execution at the very next statement in your code with all the variables intact. It's a very different deep sleep on the ESP32. Bear that in mind. Now, a couple of announcements. Okay, announcement time. Announcement number one. When I moved house at the beginning of this year, or February 2021, I couldn't reply to all comments, as you know that I normally do, so there are lots and lots of comments still sitting there unanswered, and I'm not going to answer them now because obviously it's months ago. So I'm going to remove all those unanswered comments. All right, so don't take it personally if your comment suddenly disappears, if you can remember actually writing it, because I'm going to clean up my own backyard, as it were, and get rid of all those ones so that I don't have any outstanding comments, because YouTube tells me that you've got all these comments you haven't answered yet, and it gets in the way and muddies the water for me to see the comments from, say, this video. All right, so that's the first thing. Announcement number 2. Over the years, a lot of people have said, where's your Patreon page so I can support you, Ralph? I really want to support you. And I've said, not happy with that. I don't think I'll go down that route yet. And they go, come on, we're going to win. Okay, I've now launched, or joined, if perhaps would be a better word, the Buy Me a Coffee organisation, right? So if you think I've done you a good turn, you think, yeah, I'm going to support you either as a one-off or regularly, you can go to my video description down there, or the GitHub up there. I don't know why I keep pointing GitHub up there anyway. And you can buy me a coffee. Now, the price of a coffee, a single coffee, is $5, which makes it quite an expensive coffee, really, doesn't it? But I don't get all of that. Some of it goes to the Buy Me a Coffee company or organisation, whatever they are. Some of it goes on PayPal fees. So I end up with about $4.34. And in pounds, that's about £3.20 or something, right? So it's still a reasonably priced coffee, but that's what I get. Okay, so that was announcement number 2. Announcement number 3. ESP32s behave differently today than what they did, say, 3 months ago. Why? Okay, the answer is in the format of the flash mode accessing. Now, if we take a typical flash mode set of tools, let's have a look on the Arduino IDE and you'll see what I mean. Right, there you can see a snapshot of the parameters that you can specify when you have got an ESP32. Right, the frequency, the core debug level, which I strongly recommend you put to verbose in the first instance, because there are some debugging messages behind the scene written by Espressif that you'll never get to see otherwise, and they are very, very helpful when things go wrong. Okay, flash frequency, normally 80 megahertz. If you have problems, you can put it down to 40, but I've never had a problem. Now, flash mode, that's the thing that's changed, okay? Now, a year ago, when I did my ESP32 web radio, for example, I always but always put it in as QIO. In fact, every single ESP32 I've ever owned has been set to QIO on the flash mode. Quad input-output. Uses 4 lines on your ESP32, at least, and it accesses the flash very quickly, and it's the most efficient way of doing it. Except there was a bug. When you specified QIO, Espressif seemed to interpret that as DIO. So you thought you were running in QIO mode, you were actually running in DIO mode, and that worked well. I guess it's slower, but I guess would we notice? You know, it's a good question, isn't it? And they fixed it now so that what was QIO is actually being output as QIO, except what happens to every single one of my ESP32s is that they go into continual reboot. You may or may not get a few lines of sort of debugging, but basically it means I'm foobar. I can't, and it would just keep looping and looping and looping. Well, of course, that caused me quite a bit of consternation and trouble, and I went onto the Espressif GitHub site and asked the question, and a few people came back and going, oh, is it this, is it that, you know, power and all this sort of thing. But gradually between us we sort of narrowed it down, and I suddenly realized when I reverted back to framework 3.30, and at that point I realized that although I'd said QIO, at reboot, if you look at the boot messages on the ESP32, it's coming out as DIO, all right, not QIO. So I thought, so went back to framework 3.3.2 or whatever the latest one is, and it said, oh no, I'm in QIO mode, and then the reboot started. So I thought, okay, what can I put it? Should I put it back to DIO? As soon as I put it back to DIO, it came out as DIO and it worked. And I thought, well, is there a faster one? Well, QOUT, quad output, is a little bit faster, only second to QIO, and that works fine. So if you've got problems with your ESP32s and you've specified a QIO previously, you may have to revert to QOUT. Okay, DIO is slower and DOUT is the slowest of the lot, I believe. I'm not totally sure on that, but anyway, QOUT is better because it uses more lines, so it can get the data quicker, I guess, in parallel. And finally, announcement number 4 on this little crib piece of paper where I had to tell you about QIO. That little device there, anybody identify that? I don't know how close I can get it before it goes out of focus, but yeah, it's a voltage regulator, an SMD voltage regulator. In fact, it's identical to the voltage regulator on this board here, and it's that little black blob there. Guess what happens when you connect the 3.3 volts output of this voltage regulator to ground? Does this still work afterwards? Well, I think the clue's in the fact I've had to desolder it, and I'm waiting for some spares to come from RS Components later on today. And as you can see in a little video there, I've had to cobble together a microchip MCP 1700 device at 3.3 volts just to let my smart heater controller continue to work in the meantime, because I don't want to solder up a complete new board. Yeah, so be very careful with your multimeter probes when you're touching the 3.3 volts on those boards. Whew. Okay, enough of these announcements. Let's go and have a look at a very quick code walkthrough, shall we? Okay, let's have a quick whiz through the code, all right? Not necessarily line by line, but enough to get you going, I think. Okay, so at the top, I'm using the Arduino IDE 2.0, okay, so the new version. This is beta 12, so at the top, look. And it's slowly getting there. It's slowly getting there. The emphasis on the slowly, I think. Yeah. Beta 12 gives you the control over this bottom window. Look, see that the output or whatever it is. You can turn that on and off now, which is great. Gives you more room for coding. Right. So let's start at the top and work our way through. I do have to include Arduino.h, otherwise you get red squigglies everywhere. I don't know if they're going to fix that ever, or you have to put it in forever. I don't know. Our LED pin is defined, and our button pin. Do read the comments here about which pin you're using to wake things up. Okay, a few variables here that we're just using as defines. Now, this is important. When your ESP32 goes to sleep, as I say, the memory and the code and all that just dies. It's just garbage. All right. When it wakes up, there's nothing there. So if you want to retain some variables across the deep sleeps, you must put them into the RTC runtime memory, and you do that by typing in RTC data attribute in front of your declaration, just like that. And so this int boot count will be available whenever I wake up, and I'm just doing that as a demo, and we'll output that boot count every time it wakes up from deep sleep or push button, and it will increment. If, however, you press reset or the power dies and it restarts, all those variables get wiped out. So do bear in mind that important stuff, if you're logging stuff, for example, don't put them into the RTC SRAM, put them into SPIFs, or even better, little FS, of course, much more robust. Okay, so the setup, what do we do in the setup apart from starting our serial monitor up? The first thing we do is get the wake up reason. Why am I suddenly awake? Yeah, we need to know that, so that your code can take the appropriate action within it. Yeah, you might want to, if it's a brand new startup from power up, you might say, well, I'm going to do all this stuff. But if it's just a wake up, you might think, well, I've done all that. I don't need to do all that again. I don't need to, for example, I don't know, format an SD card. I don't want to do that. I just want to keep writing to it, as an example. Okay, define a couple of pin modes. The LED is obviously an output, and the push button, I've said it's an input one, because obviously we're bringing that to ground, so we're making it low, and that's it, all done. Okay, right, so the loop, which is this tiny bit of code here, basically it's just hanging around. Yeah, it's just doing nothing except flashing the LED in this little bit here, and then counting to go, have I been in this loop for enough seconds yet before I can go back to sleep? And the seconds to hang about is, it's not going to show me, is it? So the pop-ups have disappeared now on variables. I think the seconds to hang about is 10 seconds. All right. So 10 seconds times 1,000 milliseconds, and if that's true, it goes to sleep. Right. And the LED then, of course, will stop flashing. And the go to sleep routine, which is the one down here, it basically enables two ways to wake up again. One is to say via the external RTC clock GPIO pin, and there are a few of those. And also by the wake up timer, and the seconds to sleep, I think once again is 10 seconds. Yeah, it's really annoying that they've broken that, haven't they? It's not telling me what that is. I think it's 10 seconds. And we multiply the seconds by microseconds to seconds. So I could have typed in here 1,000,000, but magic numbers. Let's keep it as a proper defined variable. In fact, I stole all that from the Espressif documentation on deep sleep. Just makes it look better, doesn't it? And then you just say, go to sleep, and that's it. Bang, your device effectively switches off. Apart from the RTC, which just trickles along very, very slowly, tiny amount of current it requires on that one with the LED and everything else, as I say, almost 3 milliamps, 2 milliamps and something. But most of that is probably the LED on it, to be quite honest. Okay, and when it wakes up, it says, why am I awake? Well, this is what we execute this one here, get wake up reason. And basically, it's a case, there's the boot. Let's do that bit first. This is reboot number or %D, so remember this is printf. Okay, log W I'm using. Let's explain that first. Within the ESP32 framework, or Espressif Framework generally, they've got log underscore something. So you can have log underscore E for errors, W for warnings, D for general debugging, and V for verbose. And you switch that on and off within your sketch itself. Okay, now this is a warning. So if I didn't want warnings to come out and I said, no, I'm only interested in errors by declaring a certain variable at the top of my sketch, this would not produce anything at all. Okay, it just wouldn't happen, which is very similar to the video we did a few weeks ago about getting rid of serial.print stuff, isn't it? Right. Let's think about the reason why we've woken up then. So what we're saying is get the sleep wake up cause. It's just a variable that the ESP32 knows about. And then we have a switch case construct here, and it tells you why it's woken up. For us, we'd expect either we're woken up by the IO, so real-time clock IO push button, or by the timer, which is this one here. We wouldn't expect this or touchpad because we're not using that, or ULP, but we're not doing any of that. I'll let you read those up in your own time. Yeah. And if we pressed reset or it powered down completely, the power failed and then restarted, we'd get this here. And chances are the wake up reason would be 0 at that point. And that is it. That is all the code there is to demo this. It's pretty simple, isn't it, really? Yeah, there's quite a few comments in there, so read those and download it and just have a play, really. It's just a nice little thing to play with. Now, as I say, there's more to sleep modes on the ESP32 than just deep sleep, although I suspect that is the one that most people are going to go for if you're really keen on saving battery power. The one here on my workbench that I'm going to be using for my smart heater controller, remote temperature sensor that also detects when the power's on in here. When the power's off and I'm running on battery power, I want the maximum battery power saving, don't I, so it can run all night. So it would definitely be going into deep sleep, which is where this video came from. And it works absolutely great. The actual device that I'm using is very, very similar to this. It's not the same shape or anything, but it's similar. And it takes overall 3 milliamps when it's in deep sleep mode, which isn't great. I mean, it should be down to sort of half a milliamp or 150 microamps. But then, of course, remember, we are powering the entire board up as far as it needs to be powered up, which includes, I guess, other components, and there might be resistor network dividers and things, all of which take a little bit of power. Yeah, no LEDs though, thank goodness. And it works fine. I've got a little battery, and I'll show you all that in due course when I do my smart heater controller video. So ESP32 Deep Sleep, I think, is the way to go. So please have a look at the code, download it. There'll be lots of links either down there in the video description for you to look at, as well as being in the GitHub. I'll do a couple of PDFs or something, so in case that information ever disappears. Don't forget, you can now support me with buy a coffee if you feel so inclined, and do like this video if you like it, of course. And yeah, I'll reply to the comments once I've cleaned up all that stuff, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.